Good afternoon, ladies and gentlemen. I'm going to be giving this presentation today on the proven benefits of Brokk machinery in conventional gold mines in South Africa. So I've got my 15 to 20 minutes, so let's just jump right into it. The agenda today for the presentation is basically just an introduction to myself and the machinery, Brokk machinery, then looking at a brief overview of gold mining in South Africa, and then the key challenges that the gold mines in South Africa currently face, and these challenges may be common to many other similar types of mining in other parts of the world. Then a brief overview of Brokk machinery, and then what are the Brokk specific benefits to gold mining as we have done. And then I'll go through some photos and information on the different applications we've used the Brokk machinery for in South Africa. And then just a few lessons learned from our practical own use of the machinery in various gold mines in South Africa. Just a quick overview of DDE, my company. We're based in Johannesburg in South Africa. You've got Cape Town down here, which is probably also quite well known. And as you'll see a little bit in a few more slides, we're quite close to the main gold mining area in South Africa. Just a quick overview of my company, DDE. We are a specialized construction and mining equipment supplier and distributor. We currently supply machinery, including Brokk machinery, to some of the major, all the major mining companies in South Africa, and many of these mining companies have operations in other parts of the world. So Sevilla, Stillwater, Goldfields, Harmony, Anglo Gold Ashanti also I know has operations in various parts of the world. Okay, just a quick overview of Brokk equipment. Basically, Brokk invented the concept of the demolition robot in the 1970s. It's headquartered in Skellefteå in Sweden, and it celebrated 40 years last year of producing demolition robots, and currently a population around about 7,000 machines in over 100 countries. So although we're talking about mining here today, and gold mining specifically is what I'm going to be talking about, the machinery is used across a range of industries in various parts of the world. Just a quick history of gold mining in South Africa. The first major discovery was in the 1880s in Johannesburg, and what was then known as the Witwatersrand goldfields. South Africa was the top gold producer for over 120 years, up until around about 2007. So we were looking at about 1,000 tons per year in the 60s and 70s. And then production peak, we produced 80% of the gold in 1970 roundabout. In total, about 50,000 tons produced, and it's estimated that about 40% of all gold currently on surface in the world, 40% of that came out of a South African mine. 95% of the gold mining is underground, so there's no open cast gold mining in the country. The gold mining industry was obviously a major catalyst for the industrialization of Johannesburg as a city, as a metro, and obviously as the country as a whole. So it basically gave birth to Johannesburg as a city, which today is a metro of about 8 million people. The other major minerals mined, just as a matter of interest, is obviously platinum, coal, iron ore, chromium, diamonds, manganese is also there. We're also sort of top 10 producer in most of these other minerals. Just a quick show of where the mining, mostly gold mining, has historically occurred and still occurring. Basically, you've got Johannesburg there, and the Witwatersrand Basin, where most of the gold has been discovered, is from Johannesburg basically down to the southwest over here. It's about a 400-kilometer arc that the ore body runs. And to date it's produced about 2 billion ounces of gold. But it faces huge challenges. From 1,000 tons in 1970, today we're standing at less than 150 tons. As you can see, if you look at the top 12 gold producers in the world over here, we line at the moment, if I'm not mistaken, about 7th. So our gold production has dropped significantly. In fact, let me just go back to that table here, you can actually see it. Now, in 2004, we were producing basically 282,000 kilograms.
down to 2015, the last time it was measured, down to 120,000, and the grade, in other words, the amount of gold found in that amount of ore brought to surface is also decreased as the years have gone by. So this is just a pie chart just to show you in brief how it's declined. So some of these countries you've got in the 1970s, I mean some of the countries you've got in 2012 weren't even producing gold in the 1970s and have significantly overtaken South Africa as a gold producer. So the big question is, well, there you can see, 2017 we were only responsible for 4.4% of all gold production. And the strange thing is, even though we're down to 4.4% of total production, we still have the third largest gold reserves under the ground. And many of these grades in these ore bodies are of a very high grade. So the big question is, why has this happened? Why have we slipped to number 7 with such large reserves still in the ground? Just a brief general overview of the environment, the gold mining environment, which will lead us to understand why this has occurred, or why it is occurring. Basically, 95% of the gold mining is deep level underground hard rock mining, and then because of this, 8 of the world's 10 deepest mines are in South Africa. Untitled and Tautona are 2 of the world's deepest mines at depths between, well, approaching 4 kilometers now, with plans to extend beyond that. The other unique thing about the South African gold mining environment is it's got a very unique reef. It's narrow, it's steeply inclined, and so yeah, that makes it even more complicated to mine. The conventional areas, in other words, the older areas where the gold is mined, the stopes are typically small, and the haulage development tunnel dimensions are also pretty small, anywhere between 3 to 4 meters in width and diameter. The mining is very labor intensive, done by large pools of labor rather than mechanized, and this has got a low level of mechanization and modernization, and this is mainly as a result of the small spaces available. There's various mining methods used to conduct the mining, and in general, most mines are very mature and many are approaching economic ore depletion. Just to mention, I'm just saying economic ore depletion because there's a lot of ore left down there, but it's not currently economical to extract it, considering the gold price and the cost it's going to take to get the ore out. So let's look at some of the key challenges. I've just broken these down into a couple of silos. I'm not going to go through all of them in every silo, but just to give you a brief summary, safety has become a major concern, obviously because of the depth of the mine. This has made it more complicated. It's become hotter down there to actually mine. Ventilation is increasingly required. And one of the major things is obviously it's taken a lot longer to get down to the working area. To give an example, the guys will go down at 5:45 in the morning. It will take them 2 hours, 3 hours to get to the work face, so they'll only really start working at about 10 o'clock. They work for 3 hours and then they start having to make their way back to the area, to the shop to come back to surface. So there's not a lot of time left at the workplace to basically do what needs to be done. And then obviously with the being pretty labor intensive, you've got many people at the workplace in those danger zones, which is obviously going to create more safety challenges. It's basically modernization has not happened to a large degree. Many tasks are still done by hand. And the thinking is that if there is improved modernization, it can extend the lifetime of these mines by up to 10 years from closure that they face at the moment, which is in around about 5 years for some of them. And then they face increasing costs. There's been above inflation salary increases. As I said, because of the depth of the mines, there's less work time at the face where the work needs to be done. Therefore, more labour has been sent into those areas to get the work done. And then we've had accelerated electricity costs, etc. A key sort of thing here is the complete loss of productivity, the longer travel time to the workplace. And then obviously with the safety issues, every time there is a safety issue, there's a stoppage of the mine to investigate the incident. That results in productivity being lost as well. Another quite interesting thing is underground mining is not very attractive anymore for a lot of the younger generation. So you tend to find that the age demographic of the underground miners is increasing, and obviously with older people doing the mining, you have a lower productivity rate. And then obviously manual labour, operating hand tools for many of the tasks that are required to be done. And then being underground mining, access is always going to be an issue. So because of the unique reef at between 20 and 30 degrees incline, it kind of limits your type of machinery you can use in that environment. And then it also obviously takes you a long time to get that machinery to the work area to get into place to do the work. And in the old gold mines, the conventional areas cannot be mined safely because they're just not safe to access anymore. And in a lot of those areas, there's still quite a bit of ore that can be extracted for good value. Okay. Right, I'm quickly going to go through the basic Brokk concept and explain the benefits of this machine to, the benefits that we've sort of basically proven in the gold mines in South Africa, so that you can get quite a good understanding of how this has benefited our environment. First of all, what you'll notice is it's a very compact machine because there's no operator cab. The whole machine is optimized to provide maximum power to the tool in the front, which is the part that's doing the work. It's got a 360-degree slew, so it can operate in any direction. It's remote controlled, so with remote control comes safety. The operator is out of the danger zone. The operator is also not exposed to any vibrations from being on the machine, which is also important. One of the key benefits, you can't see it so well in this picture, but there's a quick hitch system over here for the tool, so the tool can be dropped and changed for a different tool, a drill, a bucket, within 5 minutes by a decent operator. That can be done. So it has multiple tools available to it. And then it's got flat down outriggers to give it stability while it's working. The tracks, rubber or steel, depending on the environment. If you need a bit of grip on the incline, we usually go for rubber. What often happens with steel on the rails inside some of the older mines, steel tracks get jammed up on that and get snapped. So rubber tracks are quite a common type of track to use. Obviously, with the flat down outriggers, they can be put up, the arm can be tucked in to give you a very compact form, which makes access to certain areas a lot easier. Another key thing, even though it might look like a standard excavator arm, it's actually composed of 3 sections. What that means is it gives you a lot longer reach and also flexibility, so its ability to break upwards or work upwards and sideways is greatly enhanced compared to a traditional excavator. Another huge benefit, it's electric. There are diesel versions available, but for underground mining, you don't want fumes down there, especially if the space is confined. And another big advantage of an electrical machine is it's much simpler to service and maintain. For the mining environment, it's important for reliability and to be rugged, so we have the lights behind the covers here in this grid and protection for all the cylinders to ensure any kind of rock falling or flying around doesn't damage the arm system. One of the more recently introduced benefit or improvements to the machine is something called smart power. That basically provides a lot better reliability and smart monitoring of the engine, of the electric motor, to give it more power when it's cold and to reduce the power as the motor gets hot. Just some examples of the smart power system. It's continuously monitoring the motor to ensure optimal power depending on its temperature. With smart power has come improved. This is the electrical cabinet of the machine. All components are being sort of optimized. There's a circuit board put in there for less wiring, which gives it ultimately better reliability. So a number of improvements to improve the machine for us for mining and also across the other industries where the machine is used. The machine is available the Brokk machinery is available in 9 models. So from the Brokk 60 of half a ton all the way up to an 11-ton machine. All the machines the concept is exactly the same. They're all built remote controlled. And the only difference really as you go up the range is the size of the hammer, size of the tool increases in power, and obviously the size of the machine. So you can choose a model to give you the maximum power in the space you have available to access the site and to work in the site once you're there. All right, just looking at the tools available for the machine, there's a multitude of tools. I've put some of them on here. There are more, but these are the main ones. For mining in general, the most common tools are the hammer, the rock drill, the rock cutter. We have used the cut-off saw to cut rails underground, and obviously the grab to move around material. So as I said earlier, you can change the tool within 5 minutes, so it's an extremely flexible and versatile machine. This is just a quick overview of the rock drill. It's a specific rock drill with specific movements. In this configuration is very good for forward face drilling. You can see the movement of the drill, how it's available to access different parts of the tunnel to be able to drill close to the roof, the floor, the wall, can flip upside down and drill forward and sideways if you needed to. Just some very quick information about the hammer. In some applications you break in sideways and upwards with a hammer. So we are able to put now the Atlas Copco tunneling version of the hammers on, which has dust protection to prevent dust from penetrating into the hammer. So that's a lot better from a reliability point of view. And then obviously it's got the wooden nozzles on the front of the hammer to reduce dust. So pretty good for tunneling, which is a lot of when you're doing gold mine. All right, I'm quickly going to go through the benefits of the Brokk machine for mining, and these are very much related to the challenges that I spoke about earlier in the gold mining industry. So from a safety perspective, obviously it's remote controlled. The person stands in the safe zone and is in a safe area from any kind of rockfall that may occur while the machine is working. Access, you can choose the right model according to the work area and according to the access that's available, the entrance to the area that's available. It can be transported under the mining cage, and as I said earlier, with rubber tracks, it can travel up steep inclines where those exist, which we run into quite often. It's ultra productive, so in terms of manual tasks to be done manually by hand or by groups of labourers, one machine typically can replace about 10 people when you're talking about hammering, and then it's got the maximum power to size ratio. It's very versatile. It's one machine at a work site can replace multiple machines or multiple handheld tools, and that's the three-part arm system obviously gives it that versatility too, with being able to break better upwards, down, sideways, however it's required. And then reliability. We've proven the reliability. We have many machines working underground, and the reliability is superb, and it's been more improved now by the smart power system that's been introduced within the last year. There's a typical configuration of the machine. There's various options available. So in a mining environment, we look at the tracks, either steel or rubber. You can fit it with a dozer blade. You have cylinder protection for the machine. There's force draft cooling available. At 40 degrees underground, you might need to plug in compressed air onto the back of the machine to blow air into the hydraulic system and the electrical cabinets to prevent any kind of overheating of the system and a shutdown of the machine. The most common Brokk mining models we're using in gold mining in South Africa is basically from the 110 to the model 500. So basically your 1-ton machine up to your 5-ton machine over there. All doing different tasks. So I've listed the tasks we've done and are doing with these machines on the ground, and some are more common than others. This just gives you a brief overview of the most common tasks and where they are in the mining, So obviously with the tunnel development, some cleaning, and shaft sinking. This one is meant to indicate. All right. Obviously, to get the machine into the place it needs to work, you need to get it there first. So luckily, because of the compact size of the machine, it doesn't have to be dismantled. You can sling it underneath the mining cage and drop it underneath, which we've done quite a few times. And then this is a shaft sinking project. Typically lands on its backside and falls sort of on its tracks, and it's good to go. And obviously, if it's a smaller model, This one is slung beneath the main cage or the main lift of the shaft. If it's a smaller model, you can drive into the cage to get it underground. Just shows you what we typically look at with customers to optimize them getting the right machine or the most powerful machine into the area available. So very good measurements just to show you. Okay. All right, tunnel development is one of the very common tasks. This is just a brief overview of that cyclical process. This is how it's done conventionally, either by hand or larger machinery. This is showing you the Brokk method of doing it. Basically, you can see how confined the area is and how we're able to get the machine in there. Once in position, it can work with the drill, doing face drilling, support drilling. You can put on the hammer and do scaling, boring, and boulder breaking. Just an example of either working up in high headroom or low. This is typically showing forward break-in, pre-drilled holes, hammer used to break the face in cases where the rock is a bit softer and drilling and blasting is not necessary. This is also tunnel development. This is a tunnel showing a seismic event or bump that usually results in fatalities or injuries. It's basically a very rapid deformation of the tunnel underground. Brokk machines, obviously being remote controlled, can be sent in there to do rehabilitation of their tunnel so that they can carry on mining that area. And that's typically what it looks like once the Brokk machines have completed the job. Scaling, very common task, again, done by big machinery or handheld. This is a 110 model showing scaling in a very low profile environment. Transported around the mine on a UV because it's a track machine, so there is a bit of a speed issue, but you can put it on the back of the UV and move it around the mine. Sub cleaning, this is basically what we call bottom shaft cleaning, right at the bottom of the main shaft. There's a lot of sort of waste material. Brokk has sent down their task, usually done by hand. The machine does a superb job and it's safe and people are out of harm's way. New shaft sinking is another application that we've been involved in. This is typically the drill rigs involved. This is a loader that is typically used. Brokk is easily lowered through the stage on a new shaft sinking project. You can see it landing here. And this machine is typically used to load that kettle. In that environment, it does braking, drilling, and lashing or loading into the kettles. Here you can see the start of horizontal tunnel development using the drilling attachment. Oversized braking, another very common task after the blast. There's typically large boulders left lying around. The machine can take a very powerful hard hammer to break these oversized rocks. If it's not big enough, obviously you can drill it and blast the gap. Grizzly braking, the lower carriage of the machine can be removed and it can be mounted as a stationary unit over a grizzly for breaking the rock to be able to drop through the grizzly. This is pillar robbing, basically with a room and pillar mining environment. The pillars are left behind and these pillars are still have a lot of gold ore in them, but they have to be left in place. So it's pretty dangerous to go back in there and mine them again. But with a remote control machine, you can go in there and basically skim these pillars and get that ore out and mined. Ring set handling, you could put a beam handler on the front of the machine to handle these ring sets, which is basically reinforcements for the tunnel environment underground. Stope drilling, right at the stope face. This is a stope machine or stope rig that's been developed to operate in a 1.2 meter height headroom and doing pattern drilling on the actual reef body. It's just some enhancements that are done to the machine, a winch, basically to keep the machine in place operating on a 30-degree incline. These are some of the lessons we've learned. It obviously provides a massive safety benefit and productivity improvements underground where it's able to take over from a lot of tasks that have previously been done by handhelds. It produces a large degree of modernization and mechanization without the whole mine having to be redesigned. And then obviously when looking at the Brokk machine compared to how it's traditionally done by hand, you just got to make sure that the full cycle is actually improved rather than just a single task that the machine may be doing. And then obviously you have to be conscious of the taking over of employment or of jobs by large labour forces. If there's 10 guys that were previously doing the job and putting the machine in there Obviously, you're going to need less people, so you just got to be conscious of that and be transparent in the whole process of introducing the machine. Otherwise, it's not going to be used effectively. All right, and yeah, that's about it. Again, anzeve in Spain is the local distributor here, and there are their contact details.